Hello boys and girls, let's get out tonight's homework assignment. We'll be working on multi-step equations, and some of these multi-step actually they're only two-step equations, but some you need to simplify before you begin solving for the variable. And I'm going to talk a little bit about that with the first problem that we do together. Okay, let's get out the assignment and begin. Now, anytime we solve any type of equation where we're solving for the variable, the goal is ultimately always to get the variable in isolation. That means get this variable here all by itself on one side of the equal sign and all the mathematical junk on the other side. But now we're dealing with multi-step equations where there's multiple operations being performed on the variable. So there's a lot of inverse operations that we'll have to do to undo it, to get it isolated. But before we even begin that, you should always ask yourself, can I simplify the equation at all? Before we begin solving, we should always try to simplify. And simplify simply means we are going to check, can we combine like terms, if there are any, or is there anything to distribute? Okay, now when I look at this here, I don't see any like terms on either side of the equation that I can combine, but I do see some distribution. I can distribute this -3 to the -5 and the r. When I do that, a -3 times a -5 is going to be a +15. And a -3 times r is going to be a -3r, which is equal to 30. Now I can begin solving for the equation. Now I can begin to try to isolate the variable. And I need to look what's happening to the variable. Well, first of all, I see the variable is being multiplied by a -3, and I can also see that 15 is being added to it. Now the rule for multi-step equations is we almost want to go, since we're doing inverse operations now, our order of operations kind of goes backwards. We want to first ask, is anything being added or subtracted to our variable side? And I can see here that 15 is being added. So I want to do the inverse of that, which is subtract 15. I want to get rid of it because I want to peel away all the layers, all this extra mathematical information that's on the variable side until I have nothing left but the variable. And we know what I do to one side of the equation, I must do to the other side to keep it balanced. My 15s cancel each other out. I bring this down, and now I have a -3r is equal to 30 minus 15, which is 15. Okay, now I've got a one-step equation that's left. I look at my equation, what's left of it, and I see that 3, or I should say a -3, is multiplying, or r is being multiplied by a -3. So how do I undo that? How do I remove that? Well, I do that through an inverse operation. The opposite of that would be divide by 3. So I divide this side by a -3, and I divide this side by a -3, and I finally get r is equal to a -5, because 15 divided by a -3 is a -5. Now let's look at number 5 of our homework. We're still on the front side. I go and I always check this. I can clearly see that more than one operation is being performed on the variable, so I have a multi-step equation. I ask myself, can I simplify? Well, are there any common terms that I can combine? No. Is there any distribution? No. So you can't always simplify. It's not necessary here. So now I go to my next checklist and I see, is there anything being added or subtracted on the variable side? And the answer is yes. I'm adding a 5. Well, what is the inverse or the opposite of that? It would be subtract 5. And what I do to one side of my equation, I must also do to the other. If I take 5 away from this side, I need to take 5 away from this side. That cancels that out. I bring down my x over 2, or x divided by 2, is equal to a -5. Okay, and now, I ask myself, what's happening to the variable x? Well, it's being divided by 2. What is the inverse or opposite of that? How can I undo divide by 2? Well, it's multiply by 2. And what I do to one side, I need to do to the other side. And my 2's cancel each other out, and I'm left with x is equal to a negative 5 times 2, which is a negative 10. X is equal to a negative 10. Let's move on to number 8. Number 8, we have 3 plus a divided by 2 is equal to 1. Well, can we simplify? Are there any like terms to combine? No. Do we need to distribute? No. So now we go to our next checklist. Is there anything being added or subtracted on the variable side of the equation? The answer is yes. We're adding 3. So what's the opposite of adding 3? Subtracting 3. And what I do to one side, I must do to the other. The 3's cancel each other out. Now I have a divided by 2 is equal to 1 minus 3, which is negative 2. Okay, now I ask myself, well, what's still happening to a? Well, a is being divided by 2. The inverse or opposite of that is to multiply by 2. That's how I undo it. That's the inverse operation. And what I do to one side, I have to do to the other side. My 2's cancel each other out. And I'm left with a is equal to a negative 4, because negative 2 times 2 is 4. Let's take a look at number 14. On the back side of your homework assignment, we have a negative 10 times the sum of 8 and m is equal to a negative 130. Well, let's first see if we can simplify. Well, can we combine any like terms? No, there's no like terms that can combine, but we can distribute. We've got to distribute this negative 10. Negative 10 times the 8 and the negative 10 times the m, which would give me a negative 10 times 8 will give me a negative 80, plus a negative 10 times m is a negative 10m. Now some of you just might want to write a negative 80 minus 10m. It's the same thing. Adding a negative is the same thing as just subtracting. And all of that's going to be equal to a negative 30. Well, now I go through my checklist. Is there anything being added or subtracted? And the answer is yes. Okay, I'm adding a negative 80. How do I get rid of a negative 80? Well, I've got to add 80. And what I do to one side, I have to do to the other side. So I'm going to add 80 to that side. A negative 80 and a positive 80, they cancel each other out. I bring down my negative 10m, which is equal to a negative 130 plus 80, which is going to give me a net result of a negative 50. I have one more step left. I can see that m is being multiplied by a negative 10. What's the inverse of that? Dividing by a negative 10. And what I do to one side, I must do to the other as well. So I'm going to divide both sides by a negative 10, and that'll leave me with m is equal to a negative 50 divided by a negative 10, which is a positive 5. M is equal to 5. Let's look at number 18. With number 18, we have a negative 6 is equal to a divided by 10 minus 8. Well, there's no simplifying to do here. We can't combine any like terms. We can't distribute. But what I do see is I do see that I'm subtracting 8, and that's the first thing I want to get rid of. So I get rid of a minus 8 by doing the inverse of that, which is plus 8. And what I do to one side, I have to do to the other side. So negative 8 plus 8, they cancel each other out. I bring down my a over 10, or a divided by 10. A negative 6 plus 8 is going to give me a positive 2. Then the next step is, well, what's happening to a? I still am, there's another operation that's still being performed on it. It's being divided by 10. So what's the opposite of dividing by 10? Multiplying by 10. And what I do to one side, I must do to the other. So I get a is equal to 20. And that's my final answer. Let's go to number 22. Now number 22 is very special. There's no simplifying, no combined like terms, no distributing. But here we have the variable embedded inside of a fraction. It's not just it's not being divided by a number, it's embedded in this complex fraction here. So this is where we have a little exception here. We've got to get rid of this fraction, okay, this 7 plus a over 9. And the only way we can do that is we got to multiply this denominator by 9. That's exactly what we're going to do. When we do that, that's going to remove that denominator, and it's no longer a fraction. Okay, and then what we do to one side, we need to do the other side. So we're going to multiply -1 also times 9. Okay, so 9 times a -1 is going to be -9 is equal, these guys cancel each other out now, 7 plus a. Now I can work with that. Okay, and then there's only one operation being performed on a, and we're adding 7 to it. What's the inverse of that? -7. And I'm going to subtract 7 from this side as well. Bring down my a, because the +7 and -7 cancel each other out. A is going to be equal to a -9 minus 7. Or just think of it as I have 9 negatives and I have 7 more negatives. Altogether I have 16 negatives. There's my answer. But the key thing was here, since the variable was embedded in the fraction, we had to get this out of fraction mode. And that's by multiplying the fraction by its denominator. Okay, number 24 is the last problem for our homework assignment. It's also the last one we're going to do together. You should be able to figure out the other ones in between this video and also your notes. You should be in pretty good shape. Okay, number 24, we've got 1 is equal to x minus 9 over 4. This is a lot like our last problem where we have the variable embedded inside of our fraction. So we got to get rid of this fraction mode here, and we do that by multiplying this whole funky fraction by its denominator, which is 4. We multiply this through by 4, and what we do to one side, we must do to the other. So 4 times 1 will give us 4, and then these will cancel each other out and left with x minus 9. Okay, now we just need to ask ourselves, what's happening to the x? It's being subtracted by 9. That's kind of the question we always ask. In order to get the variable isolated, we always have to ask ourselves, what is happening to it mathematically? What operation is being performed on it? And then we do the opposite of that, the inverse operation, to remove it. Okay, x is being subtracted by 9, so we need to do the opposite of that, which is add 9. And what we do to one side, we do to the other side of the equation. We bring down our x, and x is equal to 13, or 13 is equal to x. We should flip this around. There is our answer. As always, boys and girls, I hope that was helpful. Please bring any questions that you have tomorrow to class. I'll see you then. Bye-bye.